All right, back at Build 2013, it's Going Native time. Welcome. I know you saw the Herb talk. Really stoked to have the people we have today. We have Tarek, Schroeder, and Broomer. These guys all spoke at this event. You talked about what's new for developers in Visual Studio 2013.
That's right.
You talked about C++ CX and modern Comish kind of stuff. You did the deep hardware, the elephant on the CPU, which was a great talk. So Eric Broomer, of course, sorry I didn't say your full name,
no,
but
it's okay.
This is live, man. We're moving fast. So Herb's talk, you mentioned Going Native 2013. So rock and roll, man. You guys need to register for that. You also need to ask questions. Right underneath the player, type in any question you want about C++, and we're going to put these guys on the spot and get the answers. But, you know, what is new for C++ developers in 2013?
You know, we have quite a few things. You know, we always look at what are developers, why they use C++, and there are three main reasons we hear from developers. We hear about performance, we hear about conformance, and we hear about portability and cross-platform. So we definitely are delivering on those. In addition to that, a big thing for this release was support for Windows 8.1. So a number of things that we added for connected application in Windows 8.1, all the support for all the new features for Windows 8.1, better XAML designers, etc. A number of performance features that Eric could definitely dive a lot deeper into. C++ 11 support, a new nice SDK for REST APIs and consuming REST services, JSON parsing and things like that. And then a whole bunch of nice IDE features that make people's lives easier. So it was a very nice release, and considering that this is only less than a year after the previous release, VS 2012, we packed quite a number of things that we're actually very proud of, so we hope people like it.
Excellent. Now, in terms of the C++ CX world, how have things gotten, what are some of the improvements that have been made in 2013 from 2012 in, compiler output, whatever?
One of the things we spent a lot of time was people saying, hey, it's not performant. So did a lot of investigation. We found a few issues and fixed those in our code. But at the same time, my talk was a lot about common patterns people were using that was resulting in performance issues in their code.
Okay.
So what are the guidelines and patterns? We want to put together documentation. My talk was the first step.
Okay.
So a lot of more incremental.
Okay.
And then we also tracked some of the changes WinRT made.
Okay.
Like nullable types and structs, and then there's one more thing I forgot.
That's fine. That's no problem. So Eric, your talk, you went like deep. Like,
yes.
It's all about the hardware.
All
right?
about the hardware.
So tell me a little bit about that spectrum.
Well, sure. So I mean, look, we like writing native code, but the truth is your code really runs on the hardware. It's really important to know enough about the hardware to make sure you're writing the correct code, your data structure is in the right format. That really, then the compiler can go ahead and take advantage of what you've done as long as you've done it in the right way. And really, modern processors are blazing fast, right? You've got, the Intel Haswell parts that were just released. You've got 8 wide pipelines. So every single processor cycle, you can execute 8 instructions at the same time. That's an enormous amount of bandwidth that's available. That's just waiting to be harnessed. This is why we write native code, is to take advantage of that kind of stuff. So my talk was about memory. It was more focused on the performance with regards to accessing memory, alignment of memory, stuff like that. There's things that we've done in the compiler to improve our data alignment work, our data access work. I could talk about performance for hours.
Well, all these talks are online, right?
Yes.
They're all recorded. Herb's talk was live. People saw that as it was happening. Everything will be online. I'm surprised there's no questions yet. It's rather hard for me to believe. So I'm going to sit back, pretend like I'm you, and I'm going to say, C++ 11 conformance. What's going on?
So Herb just had his talk, and he announced sort of our roadmap for how we're tackling C++ 11. So we have quite a number of features in the preview. These are things that we had already included in the previous CTP that we did post VS 2012. So now these are all at good go-live quality with the full support in IntelliSense and the debugger and static analysis and all of that. And then past the preview, are also adding quite a number of features for the RTM. We are adding more C++ 11 features like non-static data member initialization. We're also, this is one thing that Herbst announced, which is we're going to be looking at not just the C++ 11 standard, but the full C++ 11 plus C++ 14 standard, because now we know the full scope of what's coming in C++ 14. So we're actually starting by adding a couple of features from C++ 14 in the RTM as well, sort of to complete out our Lambda implementation. In addition to that, we looked at some community libraries where people had a number of C99 and C11 requests to enable some of the most important community libraries. So we went and added those features as well. So you get a good focus of a healthy dose of C++ 11 features, plus some sprinkles of key C99, C11, and C++ 14 features. And he also announced a roadmap for how we do the remaining C++ 11 features and what we're going to do, like the order of how we tackle the remaining features and which ones are going to come in a nearby CTP and which ones are going to be for later.
Excellent.
So we have a number of things in the roadmap there that are good.
Perfect.
Just to add to what Tarek said, I think Stefan has already posted a blog, or he's going to post something soon about the library side of, STL side of the C++ 11 features that we did. Should have already gone live. If not, it'll wait for it.
Excellent.
He goes into a lot of detail about what are the features and what are the key issues he ran into making those changes.
Excellent. All right. So this is Channel 9 Live. It's all about the people out there. Love to see all the questions that are coming in. Let's start hitting them. What is the best community for learning all the new C++ features? Miss the great articles, old, like in CUJ, etc.
Yeah, good question. How do you learn about all the new C++ features? Obviously everything is in the standard, but reading the standard is really, really hard. It's mostly for compiler developers, not for customers. So there are a number of sites online. I think one of the places that we really like to lead people to is the Visual C++ blog. So on the VC blog, we actually put quite a number of either links to a white paper or like a nice elaborate blog post. Stefan, for example, takes care of that on the libraries, and he adds quite a number of elaborate, here's how you use this, here's why this was done. Herb's talk that he just gave, he actually went through sort of a brief of some of the features and how they are used. And online, there are a number of tutorials that you can just looking by the name of the features, if you use your favorite search engine, you should be able to provide quite a bit of that. With that said, I think one of the nicest things is also books, and there are a number of books that are now focused on modern C++. So
excellent.
We could definitely post a link to those on our VC blog as well.
Well, Bjarne just released his book, and come to GoingNative in September, man. That's going to be a big, happy learning exercise, full of pragmatic information for the working C++ developer. It's not going to be an academic affair. More questions. Clang C++ 11 compiler is implemented using C++ 98. I assume that that's true. I'm curious if you're using C++ 11 to implement the current version of Visual C++.
So I'll take the question. I don't work on the compiler team and don't claim any expertise there, but I talk to developers who work on it.
Yes.
And our source code is pretty old. However, when one of our compiler does, I'm sure a lot of you know Jonathan, when he is adding some of these features, he has done a lot of changes when using the new features.
Okay.
So since it's old code base, it's not like everything is new, but some of the new features we are adding is using these features from C++.
Yeah, it's very interesting. Our code base for Visual Studio, is quite old. With that said, actually, there are a number of areas where we're using very advanced features. Think about the C++ REST SDK, for example. So that's part of the libraries that we are shipping with the product. This is all implemented using very modern C++ 11. So, all the kinds of things you would expect or not expect there are in it. We also, as we're implementing new features, even though if it's an old code base, we try as much as possible where it makes sense to actually use some C++ 11 features. We use, one of the things we do is that we always use the latest version of our compiler to compile the next version of the compiler.
Sure.
So we're always using a compiler that supports the most features of C++ 11. So we do add it there, and then quite a number of teams within Microsoft, not just Visual Studio, are starting to use more modern C++.
Absolutely.
So it's a good thing. I think it's picking up quite well.
Sure, and I mean, it's actually an interesting point, right? I mean, you're writing the optimizing back-end compiler, right?
Yes.
And you're using C, right, or C++?
Just like Sridhar was mentioning before, the compiler backend is a pretty old piece of software. But for the most part, just like other products at Microsoft, we dog food our own products. We use our products to make our own products, and that absolutely comes into play with the compiler, especially on the optimizer. I mean, I love writing new compiler optimizations using the latest and greatest C++ features that are available. I mean, the guys that are implementing the features work down the hall from me, right? They check something in, I should be able to use it for my day-to-day job. That's exactly what we do. I mean, the compilers that we ship build our compilers. That's the way it's been.
You didn't wear your T-shirt that your compiler builds my compiler.
Yes,
that was going to be a cool one.
Compiler.
We got more questions coming in. Thank you. All right, Zippy V, nice to see you back. What's the status of AMP?
Oh, AMP is alive and healthy. It's actually one of my favorite features of the product. For everybody else, AMP is a way to enable heterogeneous computing coming out of Visual C++. The first thing that we are enabling there is compute on the GPU, so general purpose computations on the GPU. And for this release, we added quite a few things, mostly focused on the performance of AMP. So performance of the running code. So for now, the new hardware architectures that have shared memory, GPU, CPU, we added features to eliminate or reduce copies, for example, memory copies between CPU and GPU. We added support for textures. We added support for compute shaders. We added a number of things that I think people are going to find valuable. And we're working with quite a number of customers right now, and I think that's sort of we reached the stage where we have people who are giving us feedback who want to see certain things fixed or certain performance improved. So we're doing a lot in terms of tuning the performance of AMP itself for the workloads that people are using it for. So I think this release is quite a good improvement in performance and added new features for new architectures.
Awesome. So there's your answer, Zippy. Heaven's Revenge. Whoa. From the recent revision of C++ 11, are Microsoft and the committee being too fast with future progress in C++? That's supposed to be a stable ++. Seems that cadence is almost being abused rather than useful. So that's what so basically it took the ISO committee a really long time to get to C++ 11, right? And now we have C++ 14, which doesn't have a ton of new features, right? So I guess this question is, are you moving too fast? Do you think they're moving too fast?
I'm giving you my opinion.
Great.
There are two parts here. There's a library and then there's a language. And I think it's very critical to make sure that the language has the right set of features that's required. C++ 11 missed a few critical ones, and I think those are going in the 14 standard.
Okay.
On the library side, though, I would like to really see it go faster. There are new technologies coming in. Right. I mean, for example, you take the web services and the REST APIs and all of those, having a good standard library for that in a short period of time is beneficial to the community.
Absolutely.
But that's my differentiation. Language, we should make sure the critical pieces are there, and libraries to make sure that people are able to continue with their C++ investments to target new technologies.
You know, that's a wonderful point, because back in GoingNative 2012, Herb had announced, or he had mentioned and talked about in his keynote, that the new focus should be on modern libraries. So modern libraries of convenience.
Yes.
Rather than having to roll your own this and that, and people like to roll their own things, but they also like to be able to write a few lines of code to get something mundane done, like make a request. Now you guys have done that in Casablanca, which is awesome. But I am curious, like how much more is actually going on in the community?
Yeah, so again, like my opinion, this is a very opinion-based question, right?
We love opinions.
And my opinion is I actually think that 11, 12 years between standards is too long. I think the programming world is moving quite fast. We're seeing new innovations come up, and the improvements in hardware are actually causing changes in software that you need to react to. And waiting 12 years is a very, very long time. So I'm quite happy that we're going to get, two standards in every decade as opposed to one standard in every decade. I think that's a useful and good thing. The features that are being added is not actually adding complexity. Like there's a complexity in the language now, and a number of the features that are being added are added to reduce some of that complexity. Like for example, the initialization features. You're going to initialize the code regardless. Why have to write a bunch of code to initialize it? Why not just have it in line with where you're defining it? I think these are actually good and healthy things useful for C++ developers. That's my opinion.
Excellent. It's a great opinion. So how can we optimize our code for ARM devices since usually they don't have the same hardware as full PCs?
Usually they don't have the same hardware as PCs. That's an interesting statement. That one's tricky. So look, there are definitely architectural differences between the standard x86 AMD 64 compared to the ARM stuff. For example, ARM processors for the most part are in order, so they'll actually execute the instructions in the order that they were written in for the most part. And I mean, when the optimizer is actually split into two parts. We have a series of optimizations that are going to apply to all architectures, and then we have the architecture-specific stuff. And I mean, even since 2012 through 2013, we've added a ton of ARM-specific optimizations that are going to do better register allocation, better loop optimizations, fully aware that there are hardware differences. So if you're asking what do you need to do to change your code to make sure that it runs faster on ARM, well, for the most part, you can really let the compiler handle that, right? As long as you're able to profile and ensure that the compiler is doing a decent job. I mean, there's 8 times more registers available on ARM than there are on x86. That actually lets the compiler do a lot more.
Sure.
And we absolutely take advantage of that.
Right on.
I hope that answered.
It does. And speaking, since we're in compiler world, one of the things you guys do is auto-vectorize. You talked about that in your talk. How can developers check to see if you actually did it right?
Yes. So we have a compiler switch that the capital Q.
I think you have a blog.
So look, we've got compiler switches that help tell you if something was vectorized, also if something was not vectorized. And we've got a series of blog posts on the native concurrency blogs, written by Jim Hogg, the program manager on the optimizer team. And I think he did a great job explaining sort of from the ground up what automatic vectorization is, why it makes your code go faster, and then we've got a great cookbook of, hey, you've got your source code here, you've got your compiler, and you've got your cookbook on the side, and you just start iterating and make your code run faster and faster.
So go and read the in-depth answer. We're going to get to some more questions. Richard Hine wants to know, what kind of IntelliSense improvements have been made in VC 2013?
Quite a bit, actually. We focused on productivity to make sure that developers are actually quite effective while writing their code. So one of the things that we added, in addition to just the normal things that we always do, which is make IntelliSense go faster, we also added some features for easier browsing and moving between pieces of the source code. So for example, code formatting. Use the IntelliSense engine now to be able to nicely format your code. You can specify where you want your curly braces to start, where you want them to end, where you want your semicolons, how many spaces, what kind of tabs, what kind of indentation, and we have like some, over 30 options that you can tweak. And then as you're typing code, we automatically format the code as you type it. Or if you're pasting code or something, we just paste it exactly the way that you've specified. It's one of my favorite features for productivity this release. We added things like while you're typing, automatic curly braces. One of my favorite features that I've been waiting for a long time is switching between headers and CPPs. You just type Control-K, Control-O, and you go to the header or switch back to the CPP. So that's a very nice feature. What else do we have, Sridhar? We have Peek.
Yeah, we have Peek, which lets you have a summary of your source code instead of the scroll bar, and it's easy to scroll. There's the scroll bar, and then there's the Peek. Yeah. 2 different features.
Sure.
And in the IntelliSense, I think one of the interesting points is, yes, we have improved performance, but other key is not having errors or being better in the IntelliSense, because IntelliSense has become a very critical productivity feature. At least for me, it's like 99% of the times I just type in the code, there's no compilers. There's logic errors, but no compilers, and it's all because of IntelliSense. It's great, and the team has done a lot of work in making sure they're correct and all of those false positives or things that we were not erroring earlier. I think you get errors now, and makes it really.
On the topic of the errors and the squiggles, one of the coolest things is the scroll bar now. We have options for the scroll bar to make it like a full scroll bar that shows you a thumbnail of the source code in the whole file. And in that thumbnail, we actually show all the squiggles, wherever you have like a breakpoint, where we have errors, all of that is shown on the scroll bar so you can quickly move. If you're finding something that's in 6 different places, we quickly show you on the scroll bar where that is so that you can move to it. It's some very, very nice features.
Great, so you guys are making some real advancements in the productivity space. That's awesome. Mr. C64, do you have plans to modernize ATL? Isn't that what you did already with WinRT, C++CX? Do you have plans to modernize ATL with new C++11.14 features? He then says, currently ATL seems basically a C++98 library with just some movements, move semantics added in CCompiler, CCombeast, or blah, blah, blah.
So we didn't look at ATL this time around too much. But we can definitely look at it and see if it makes sense to make those changes. Even WRL, we did not make a lot of changes because Windows is using WRL, and it just, from a schedule point of view, it just didn't work out as to when they were getting the new compiler and for us to make the change. Okay. But next time around, WRL will definitely be modernized. And then ATL, we need to take a look.
I mean, it kind of brings up an interesting question before we have a few minutes left here. It'd be good to kind of talk about this. When do you, so for example, if you have an old code base, and a lot of people who live in this space do, I mean, sometimes it's not always going to be a great idea, for example, yes, to use smart pointers in a code base where you're using a lot of raw pointers, right? I mean, you can get yourself into situations where just using modern stuff because it's modern might actually not be a great idea depending upon what you're doing. Can you talk a little bit about where folks can get a better understanding of that, right? I'm not just going to use C++11 features because they're here.
Yes.
They need to make sense.
There are definitely places where you want to use it.
Yes.
Right. And there are, at the same time, you don't want to have churn for churn's sake, because there's going to be regressions. You are going to hit these issues. Mm-hmm. And especially in a library like ATL, which is very widely used, if we make those changes, I'm sure we'll break somebody. So we need to be very intentional about which parts we pick and choose. But there are some places, right? I mean, if you're doing memory management, I would say use unique pointer. Don't do call new and delete.
Okay.
Use unique pointer.
I really hope we get to a world very soon where C++ developers are just always using the shared pointer variants.
Yes.
Instead of new and malloc and these things. I think we're already in a place where we can do that.
We are.
Yeah.
Now, what about when you have an old code base where you do have a lot of new and deletes? This doesn't matter.
Yeah. That's all right. They can stay like that. You don't have to go refactor all your code and change the allocation of all your existing things before you start using unique pointers and shared pointers. You could just use the new stuff and keep the old stuff the way it is, and take your time in revamping your source code at your own leisure.
Just to give you an idea, right? I mean, I and Eric have worked in source code bases that have been old, and when you're in some area and you're making a bug fix or you're making some significant changes, go change that whole file or whole function to use the new patterns where appropriate.
Okay, excellent, man. So we have a bunch of more questions, so we're going to try to be snappy on these answers. Let's go. So, has there been any concurrent data structures added to the libraries?
Concurrent data structures added to the libraries. I don't think we added any this time around.
I don't know.
Yeah.
No. Okay. JB wants to know, can you share more about __async in C++?
Async and await. Did you want to talk about that, or do you want to talk about
so we are looking at, there's a proposal that we have submitted to the committee about async and await, which is, today we have PPL, which is great. It helps you do async programming, but await and async just takes it to the next level.
Absolutely.
Just makes your code so much more readable. Yeah. And yes.
We just really think that this is going to be a pattern that people are going to be using going forward. Asynchrony is important. It's going to be used everywhere, not only in WinRT APIs, which was the main incentive for us to start looking at this, but everywhere in C++. We think asynchrony is going to be important. So we're starting with a pattern. We're working with a number of people around the ISO standard community who have a vested interest in making sure that we have a great support for that in C++, and we think we're going to have a good proposal.
Awesome. So let's see. How much C++ AMP is being used inside Visual Studio itself? And even the low-level compilation process, pre-process, load balance, and offload to the GPU. So do you guys implement GPU inside of the compiler, inside of your optimizer?
That's an interesting idea. We do not do that in the compiler space right now. It's pretty tight as it is. We did, however, multi-thread the compiler backend starting with Visual Studio 2012 to get better compiler throughput when you're doing large whole program optimizations. I'm not sure if the compiler is really the right target for GPUs. Now, there might be other parts.
There are a number of products inside Microsoft that actually use C++ AMP,
Okay.
And we have very, very good traction with them. But so it's being adopted by, there are at least 4 products that have shipped already with some C++ AMP support, and more are coming down the pipeline that we're working with.
So we only have a few seconds left, unfortunately. Well, I will say this, though. There's a lot of questions, and a lot of them are great questions. I say bring them to Redmond in September 4th through the 6th. It's going to be streaming live, but you should actually be there. Bring these questions to Redmond. There'll be a lot of the C++ team there you can talk to.
Yes.
So thanks for joining us, man. Great to see you again, Terry.
Thank you, Charles, again.
Shooter, Eric, great job, you guys.
Thank you.
Thanks.
Gone native.